All right, so this is going to be number 5 in the series of analysis videos on elastic collisions. This time we're going to look at a Pasco setup instead of an air track experiment. So we have Pasco cards and a metal track, a low friction track. So over here we can see the masses of the cards. The red card and the blue card, they both weigh 270 grams individually. So what it's going to do is going to add a bar on top of it, I think 2 bars, and they each weigh 250 grams. And so we will have a mass ratio of 270 versus 520 grams.
We want 270 and 520. Well, I'll start with the blue stationary, but we want one of those. I think 50 grams plus 270.
Yeah, 250 plus 270. So small mass against bigger mass.
Is 520. So there's the blue. Red's going to come in.
Yeah, so it's in the top left corner. You can't see him doing it, but here we have the graph, the digital graph. And these are the results.
I've got a red actually recoiled there. So let's analyze this. So let's start with the red. Red. So we want just before the collision, don't we? Just before.
So this is the velocity of card 1 before collision, which is 0.650 meters per second.
So the red came in at 0.650. The red recoiled.
And then the reflection velocity
minus 0.181.
0.181.
Okay, blue.
And then the velocity.
Blue started at 0, didn't it? But the blue went on fast. 0.428.
So the velocity of cards of the heavier card after collision was 0.428 meters per second, and that's all we need to know. So now, again, I've done the calculations beforehand, and so let's take a look at it. So as usual, so the prediction for card 1 after collision is, so the initial velocity is 6.650 meters per second. After collision, the prediction is 0.205 meters per second, and the actual result is 0.181 meters per second, which is a difference of 13%. There is a pattern in all these analysis videos until now. The pattern is that at least when the first card reflects, it always is supposed to be going a little bit faster according to the predictions, but in reality, it always reflects with a little slower velocity. So it's always the first card, the difference between collision and the difference between prediction and result is always a little bit bigger, is always bigger than the other predictions. So this one that seems to be significant. And then, okay, so the prediction for card 2 after collision is 0.444 meters per second. And the result is 0.428 meters per second, which is a difference of 3.73%, which is a pretty small difference. So for the second card, the prediction and the result are always a small difference. So that's pretty reliable. Now the conservation of momentum. The initial momentum before collision is 0.7055 kilograms meters per second. And then here we have the momentum of card 1 after collision, the reflection, and the momentum of card 2. Oh, you couldn't see my mouse, right? Sorry if you couldn't follow along. The momentum of card 2 after collision was 0.2225 kilograms meters per second. And so when you add those together, again, we treat the first card, which reflects as a negative momentum. So when we add the negative momentum with the positive momentum of card 2, we have a total momentum of 0.1737. And So, and the initial momentum, total momentum was 0.7055. So we have 0.1737 versus 0.7055, which is remarkably close together. It's only a difference of 1.02%. So this is very significant that that again, when we treat it as a vector, so when the reflection is negative, when we treat it as a negative momentum, okay, then these numbers match really well. So it must, so each time with all these analysis videos until now, especially for the conservation of momentum, when we treat it as a negative momentum, as a vector, and then they always match really well. It must be a real coincidence each time that these numbers approach so well, okay? So it must be a sign that yes, somehow we have to treat it as a negative momentum. It's not a coincidence anymore. It's very significant. Okay, so for the conservation of kinetic energy, total amount of kinetic energy before collision is 0.0570 joules. And yeah, so the kinetic energy of card 1 and card 2 together is 0.0520, and the difference is 8.7% between the total energy, kinetic energy after collision, and the initial total amount of kinetic energy is. So the difference is 8.7%, which is a little bit bigger difference than in the other examples. But I guess it has to do with the fact that that we are dealing with a track, a low friction track. I guess that an air track still has less friction than a low friction track. So again, I want to state once again that it is really significant that when we treat momentum as a vector, and which means that when one part goes the opposite way, we have to treat it as a negative momentum. Okay, so when we add the momentums after collision, when we add those together, so minus plus a positive, so a negative momentum plus a positive momentum. In this case, when we add them together, the total momentum approaches the initial total momentum really well. It's very significant, and also in the previous analysis video. So explain to me if this is wrong, if momentum can't possibly be negative, then why do these numbers match so well each time? Why is the difference always so little? Okay, so yeah, short. I'm not gonna turn this into a long video. All right, so till the next time.